Rose, I get it's frustrating not getting every question answered, but there's 28 students in here that aren't doing what they're supposed to do, so I'm trying to help as many people as possible. I'm not saying it's your fault, I'm just saying I'm trying to get to everybody, I couldn't get to you. Okay. Has anybody even taken the time to try to figure out what makes these lines parallel? First off, do we know they're parallel?
Yes.
How do we know they're parallel? So, what kind of angles?
Parallel.
What kind of angles?
Correspond. Them congruent.
Okay, hold on a second. Stop. Listen. Lonnie, can you say that one more time? Okay. What did she say? Correspond.
Oh shit, we said that.
Okay. Then you need to speak up. You were literally in the back
Right at me
room.
when I said it.
He said it like he said it.
Did I acknowledge it?
No.
So did I hear it? If I heard you, I would have acknowledged you,
You
Caleb.
looked dead at me. You looked right at me. He said no.
I looked dead at
And
Matthew
then
a
she
second
said it
ago.
too.
Did I acknowledge her? No. So did I hear her? No. See, this is also the issue of why we don't just start all talking over each other, because some of us, multiple of us, may have said the correct answer. But if we're all talking over each other, can I listen to 20 people at once?
I said it first though.
No.
You said it correctly first, or you said it first?
That was the first thing I said.
No. You said that before anyone else said anything.
Yes. That was the first thing I said.
I did not hear you, and Ari is corroborating, so I believe you. However, I'm at the front of the room and I cannot hear you. Brandon, are you paying attention right now? You're literally talking to Gabe.
Keep talking to me.
Congratulations, you're also responding? How do you not understand the issue here? So, Caleb, what kind of angles are these? Corresponding. And see, even just in watching your mouth, I barely heard you. You got to speak up if you want me to acknowledge that you got it right. So, corresponding angles. And those corresponding angles are what? Raise your hand if you have the answer. Ren? They're congruent. Right? So, Alana, what do we know if these corresponding angles are congruent? Those two lines are? Lines can't be equal or equivalent.
The same.
No. I heard someone over here say it. Say it louder. Parallel.
Parallel.
If corresponding angles are congruent, we know those lines are parallel. So we know that they are parallel right now. We used GeoGebra to construct parallel lines, which is why you had to use the correct tool and pay attention to things, right? There's literally an option that says parallel there. Now, the whole point of this, though, is to figure out what actually makes them parallel. You know by definition, parallel lines never what? Intersect, okay? The mathematical word for that is intersect. But what is making that happen? Too many of us have been goofing off, not actually even trying. Even if you didn't get the transversal, you still could have followed the first set of instruction I gave you to go look at the algebra and see what is making those lines parallel. So I'm going to go to algebra.
The point.
Something specific about those points. So I've got line. Look right here. Here's my two parallel lines. Does anything about them seem the same?
Yeah.
Yes.
Or the first round.
The slope.
Oh, the slope is the same? So in my parallel lines, the slope is the same. How about you go look at your parallel lines? No, you don't have too many numbers. Oh, by the way, if you need to, go change your settings. So click on the gear for settings. Go to settings. Click on the gear again. And change the rounding to 2 decimal places. So go to the gear again. And change your rounding to 2 decimal places. So again, if you did not catch that, to make your life easier, go to the gear, go to settings. So go to the gear again. Go again to the gear for settings. And there's where you can change your rounding to 2 decimal places. That will make your life much easier. Okay. So all that being said, does anyone else see that their parallel lines have the same slope? Darren, it helps to go to algebra if you want to look at the equations.
Yeah.
Matthew, it helps to go to algebra if you want to look at the equations. It also helps when you pay attention to directions and you don't go to the geometry, you go to the calculator suite. You did all this in the wrong spot. You see right here where it says calculator suite because it's supposed to be .org/calculator? Yep. So, you're not doing what I asked you to do. I asked you to look at your parallel lines, and we already discussed that our parallel lines have the same slope. Do yours. How did you manage? Yeah, you're right. I messed you up. My bad. You weren't. The parallel lines are at the top, dude. No, you're looking at a point. How is that a line? So you should be looking at algebra, you should be looking at lines. Do the lines have the same slope? Your parallel lines. Do they have the same slope? Don't hit the play button. Yeah? Do they have the same slope? Actually, you have the same line twice. 3 times. There it is. That's your parallel line. Alright. So, all of that being said, what notes should you make to yourself on the back of that GeoGebra sheet?
The x values of 2 parallel lines are the same.
The x value is?
I mean the slope.
The slope. I would, if I were you, write down your 2 parallel lines, the equations for them. If you did not get 2 parallel lines, write down my 2. But on the back, the notes I would make are, hey, y equals mx plus b. Right? Start with that generic equation. And so these are my equations. And so we want to notice that what is the same in parallel lines? The slope. If you have parallel lines, the slopes are the same. That's the big note to make here. If lines are parallel,
The slopes are uniform.
the slopes are the same. And I would, if I were you, make sure that I make a note about what that equation is, because you will have to know that for some features. Hey Brandon, weirdly enough, his hoodie has nothing to do with the math you're learning. Your what?
There was something on his hoodie.
Really, because it looks like you were grinning about to do something dumb when you should be paying attention taking some notes.
I told you, bro, your smile too.
So, if you haven't already made this note, I would make the note that this is the slope, intercept form of a line.
Oh yeah.
Okay? And so what do we mean by M?
Slope.
Slope. Hopefully we know how to calculate slope, right?
Yeah.
How do we calculate slope?
Rise
Divided by run. Was there any other ways? Delta y.
Divided by delta.
So what do we mean by that delta?
The change of y.
The change in y divided by the change in x. Okay, so those are that's how we calculate slope. And then when we say intercept, which intercept are we referring to?
P.
The parallel line, I mean, no, B.
Oh, wow.
What?
The which intercept?
Wow.
The y-intercept. So when we say intercept here, we are talking about the y-intercept. So it is the point 0, comma b. That's an important thing to notice. But does it matter what the y-intercepts are to have parallel lines?
No.
No. So Mari, does it matter if we have the same y-intercept for parallel lines?
No, we don't.
Okay. Focus and write that note down so that you don't forget it later on understanding checks and tests. Okay. So the y-intercept does not matter for parallel lines. You gotta have those notes. From there, we're gonna have to just go over this one together. What is the next set of instructions asking us to do? No. Look at the bottom half of the front side.
Select tool. Show.
But I'm talking about the bottom half of instructions where it says create what kind of lines?
Perpendicular.
Perpendicular lines, okay?
Go to that tool again.
Okay? So I'm going to create a line to start.
Other way.
We clear our time?
I would clear it if I were you.
Clear what?
There's an option somewhere.
It's by the little.
There it is. If you click the 3 little dots up here, or the 3 little lines up here, you can hit clear all, and it'll clear everything out for you. So I would clear out everything from the parallel lines so we can look at perpendicular lines. 3 lines. Clear all. There you go. Alright, so we should look at something like this. It doesn't matter where you draw your line. How am I going to make a perpendicular line?
The tool, the perpendicular.
So I'm going to go to tool, and there is literally a perpendicular line tool. Right? Can we see that perpendicular line tool right there? Okay? Now when you click on it, what directions does it give you? So it's a point and the perpendicular line. So I'm going to actually make a point first. So I'm going to make an extra point outside here. And now I'm going to do a perpendicular line through that point. This is much like what you did for parallel lines. But there it is, perpendicular. How can I show that those lines are perpendicular?
You gotta do your brain.
90-degree angle triangle.
I need to do what to figure out if they're 90 degrees? Measure it, right? So measure your angle. Now, how many points do you need to measure the angles? 3. So I'm going to put one at the vertex. There's that vertex there. Now I'm going to measure that angle. Remember, if you get one that is too big, delete the angle measure and just go in the different order. And I want you to notice what did it actually make for you right here. It made that box and it showed you as 90 degrees, right? So it is automatically telling you that those two angles are, or those two lines are what? Are perpendicular. So, hopefully we got that, but I need you to pause and I need you to listen very clearly to this. What made lines parallel? They're what?
Slope.
Say that again? The slope. The slope is what made lines parallel. What is going to make them perpendicular? Wait, what made lines parallel?
The slope.
Their slope. So what should we probably look at to see if they're perpendicular? The slope again. That's a great guess though. We looked at slope and then you might think y-intercept, but notice, do these have the same y-intercept?
No.
No. So we're not looking at the y-intercept. Remember, the slope is the rate of change. And so these have very different rates of change. Parallel lines have the same rate of change. They have the same slope. Let's look at these equations. Ooh. Those slopes don't look very pretty, do they? Can anyone see what the slope is for my first equation?
Nope.
For 80.
Mari, can you see what my slope is for the first equation? The slope for my first equation?
Oh,
You should not necessarily have the same. You should have a perpendicular lines, but they don't have to be the same as the ones I have. You will have something that's similar in a second. What's the slope? Exactly. You're busy talking instead of paying attention. That's what I'm talking about. Can anybody tell me what the slope for this first line is? Alana?
0.38.
Close. There is a negative here. It's hard to see that from back there. But the slope here is negative 0.38. Rin, can you tell me the slope for G right here? 2.6. No, okay, be careful. Is the x part of the slope? Remember, it's just mx plus b. So this m is not part of the slope. Now, hear me very clearly on this. Are those the same slope?
No.
No. I want everyone to go to the bottom and in the input, I want you to type in negative 0.38 times 2.67. Type in negative 0.38. Where it says input, type in negative 0.38 times 2.67. Shift.
times what?
Is one way to do it.
Times what?
Remember, that
Oh,
symbol above the 8 gives you multiplication. Negative 0.38 times 2.67.
Negative 1.0146.
Man, what's that really close to? Negative what? Negative 1? Okay. Did anybody else already get parallel or perpendicular lines and then they know what their slopes are? Nobody? Nobody got perpendicular lines? Rose, you got perpendicular lines? So your slope was 0.71 and what? 1.4? One of those has to be negative. 1.4 and negative 0.71. Alright. Can someone, not someone, I need you all, do this again. Type negative 0.71 times 1.4. Type that into the input. What do you get? Go to input. Type in negative 0.71 times 1.4.
Ooh. You get
Negative 0.994.
Hey, what's that number really close to?
1.
Not 1,
Negative.
negative 1. So if we multiply, now please hear me, part of the reason why we're off is because we're rounding. If we multiply the slopes of perpendicular lines, what are we going to get? Negative 1. Every single time. If you check your perpendicular lines, and this is the final note you need to make on the back before we pack up. By the way, what's a way to say multiplication? There's a P word for it. Product, right? The product of the slopes. Hey, it's time for you to write some notes right now. This is why we don't know what's going on understanding check and test, because we're not taking notes. So get that back out, Gabe, and you still have 3 minutes. Take some notes. The product of the slopes for perpendicular lines. Hey, what symbol can I use to indicate lines are perpendicular?
that little dookie line.
Looks like a what? Upside down T. So the product of the slopes for perpendicular lines is always what? Negative 1. We're going to talk more about that tomorrow, but I don't have the computers tomorrow, so we had to get through that. Hey, I need us to stop and I need us to talk for a second, because for the most part, today was awful. There are very few of you who are going to get good scores on active collaboration because you are busy talking about everything except for the math. Alright, I don't need your tongue sticking out and you wagging your head. I'm talking about you partially because you are not talking about math a lot of times.
I usually get like C.
You and I both know you weren't talking about the math. That's why you couldn't tell me you were talking about the math.
Because what I was talking about was personal.
Right. So was it about the math? It doesn't matter. Were you talking about the math? Were you learning math in class today? Or were you busy talking about everything else?
Sesame Street.
When you talk about the math, you will learn. That is plainly put. Tomorrow we will come to class, we will learn a little bit more about parallel lines. Excuse me. Sit down. I am talking.
Sit down.
Go.
You got 20 seconds. If you want to leave with that bell ring, you better sit down. Hey, I will pick up the laptops. Sit there. When we come to class tomorrow, we will learn more about parallel and perpendicular lines. And you will actively work the entire time. Is that clear? Yes, sir. Get out of here.
Thank you, bro.
I will get the calculators. I will get the laptops. I need you to follow directions.
I got you.
Thank you. Yeah.
And
Yeah.
I've been having to stay up and take care of my nano couple